Hello and welcome to the Defense Tech Podcast. It has been a great season so far, chatting with the hub leads from Microelectronics Commons and hearing about all the critical technology that's being developed under the program. So far, we've heard from 5 hub leads who have shared about their hub's projects developing tech such as quantum computing, AI hardware, commercial leap ahead, and more. This week we're going to hear from Stephen Crago and Mike Haney, who help lead the California Defense Ready Electronics and Microdevices, or CA DREAMS Superhub. Stephen is the director and principal investigator of the CA DREAMS Hub at the University of Southern California. Mike is the deputy director of the CA DREAMS Hub at the University of Southern California, as well as the director of the MOSIS 2.0 initiative, which you'll hear more about in the podcast episode. In this episode, we cover electromagnetic warfare, 5G, 6G technologies, the CA DREAMS MOSIS initiative, cross-hub collaboration, and more. Before we start the episode, I'd like to encourage our listeners to follow our show on Apple Podcasts and Spotify and leave a review if you love it. It's important to us to bring you the most relevant and informative content, so if you have a suggestion for a topic or a guest that you'd like to hear from on the show, you can reach out to me at sydney@nstxl.org. That's SYDNEY@nstxl.org. Enjoy this episode with the CA DREAMS Superhub. Hi, you guys. Welcome to the podcast. I'm so excited to learn more about you both and the California DREAMS Superhub. I would love to start out by giving you each a minute to tell a little bit about yourselves and how you ended up working in the defense tech industry.
Well, I'm Steve Crago. I'm the director of California DREAMS. I work at the University of Southern California's Information Sciences Institute, which is leading the hub. And I have been here since grad school. I started as a graduate research assistant at ISI and have been here ever since.
Great.
Hi. Well, I'm Mike Haney. I also work at USC ISI. Been 2 or 3 years here now. My history is I was a long-term professor at the University of Delaware, but also during that time I spent 2 stints in DoD service, government service, one at DARPA, 4 years, and then several years at ARPA-E. So I've been on both sides of the fence, but I've done a lot of research and on both sides in defense-related research and development.
Well, okay, thanks for sharing. So you both are at the University of Southern California, where you head up the California Defense Ready Electronics and Microdevices Superhub. Try to make sure I said that all correctly. So first of all, what is a super hub and how is it different than a regular hub?
Well, that's an interesting question. We took on the name of Super Hub during the proposal stage of the Microelectronics Commons. We started as a Southern California hub, and then we had a brief time when we were considering combining with the Northern California hub that was led by Stanford. And so at that time, we called it a Super Hub because it was a combination of 2 hubs. We ended up proposing separately, but we didn't lose the Super Hub. But I think that the name kind of still fits because with our MOSIS 2.0 service, we're providing services across the program for multiple hubs. And so I think that's how we earn the right to keep that name.
Nice. Okay, very cool. I always wondered how that was different. So how did the CA DREAMS Superhub come to be? Like, how did you gather and decide that you were going to propose for Microelectronics Commons?
Yeah, that's also an interesting story. So it started as a group of faculty members in Southern California who were all interested in electronic design automation. So it was a group that included people from USC, UCLA, UC San Diego, maybe one other university, I'm not sure. And then we started to hear about this program called the Microelectronics Commons that had to do with lab to fab. And none of us had anything to do with fab. It was just EDA and kind of software people. And so we realized we needed to start adding some of our friends that were involved in our nanofab labs in the university. And so then we had a group of faculty and researchers that were interested in microelectronics and had the lab part. What we didn't have was the fab part in the defense industrial base. And we found out that there was a parallel group of industry people that were similarly meeting who had similar ideas and interested in collaborating. And so we brought these 2 teams together, and that's basically the basis of our hub. It came together very organically.
Yeah, absolutely. So all the hubs act under a shared mission, which is advancing domestic microelectronics technology. But what is CA Dreams' particular mission? Like, what specifically are you guys passionate about?
So the two technical areas that we're focusing on are electronic warfare and 5G, 6G. And those two areas, from our point of view, are really one technical area. It's all in the area of RF, or radio frequency microelectronics, centered around compound semiconductor, but including silicon microelectronics.
So you just mentioned your two tech areas, which are electromagnetic warfare and 5G, 6G. So what does your hub specifically bring to the table for these critical areas?
Mike, do you want to take a turn on this?
Sure, sure. Well, another interpretation of the term Superhub is that we have 7 compound semiconductor nanofabs at 7 universities in Southern California, and 3 world-class full-flow fabs in compound semiconductors at our DIB partners, Northrop Grumman, Teledyne, and HRL. So I like to think of these 10 labs and fabs as one integrated Superhub. And as Steve said, we go beyond that too, and we're working now with other hubs. So I think that's the answer to your question. What we bring is a really comprehensive set of tools and people, critically people who can be integrated into one organization, and that's the challenge. So it's not 10 different organizations working on different things. It's 10 working on the same thing, whether they're projects or building MOSIS 2.0 and that kind of thing. So.
Sounds like you have a lot more hands, just like a lot more people than maybe some of the other hubs do that are involved. Is that right?
Yeah, I would say we have on the order of a couple of dozen people who are on the team, and more than half of them are distributed to our other teammates. So for instance, each university has 1 or 2 people we designate as a MOSIS 2.0 person under our PIES team, Process Integration and Engineering Services team. And the same goes through for our DIB partners. And then we have a core group of about a dozen people within USC ISI that sort of organizes things, handles the MPWs, and our other business at MOSIS 2.0.
Great, wonderful. Cool. So
Sydney, I was just going to say the other way we can answer that is we know that many of the other hubs with their initial hub operations budgets made significant investments in equipment and tools. We made the decision in our hub that we were going to leverage the tools that we have, and we really didn't invest in new equipment. We invested in a team to make the equipment that we have accessible for prototyping users across the country.
Yeah, okay. So I would love to hear a little bit about the project that CA Dreams was recently awarded in the first round of project awards. Are there any of those projects that you guys would like to highlight?
Yeah, we had 2 big projects, so it's easy to decide which ones to highlight. Both of our projects are led by Northrop Grumman, one in the area of 5G, 6G, and the other in the area of EW. Our 5G, 6G project is developing new phase array technologies for higher performance communications and other RF applications. And our EW project is developing new gallium nitride technology. So it's a material and device focused project developing new transistor technology for better EW performance.
So I think next I'm going to have you walk me through a couple of the critical technology areas that we talked about, EW and 5G, 6G. The first being electromagnetic warfare. First off, would you be able to help me understand why this tech area was deemed critical for the microelectronics efforts in the first place?
I'll take a shot, Steve, at that. Yeah, the EW is, of course, a big area of interest for the warfighter, for the Defense Department. And as EW has come more to the fore, and it's now dominant in every battle space that it's there, it requires more and more advanced technology, microelectronic technology. And to get to the power levels and the bandwidths and the speeds needed, it means we have to go to mostly to the compound semiconductor regime, which is where things have been developed in the nanofabs and in our bid partner fabs. But they need to be accelerated. That's the point. We need to be able to move things from the research and development side to the fabrication side and to the product side quicker. And that's the goal of Microelectronics Commons. And EW is probably one of the best exemplars of an application space in which we can get real payoff by accelerating that lab to fab microelectronics in compound semiconductors. And our two projects are very good examples of that, the two funded projects. And they're going to advance technology dramatically, but the key point is we're going to do it faster because we're going to use the hub model to do that.
Mm-hmm. Mm-hmm. Okay, and you just mentioned that EW project. So could you also help me understand what specifically that project is working to solve within EW and how this will help re-onshore microelectronics manufacturing capabilities in the US?
Sure. Well, the main technology is gallium nitride, which is used in lighting and other things. And our team has expertise at every level of the supply chain. So the project itself begins with the epitaxial crystal layer itself and the wafer. And we have a couple of companies that are looking at advancing that process. And then that is turned over to fabrication teams, parts of the team, and then packaging teams to bring it all together, and then to test and evaluation teams. So that it's really a highly vertically integrated team. It's a big project, by the way, one of the biggest, I think, in the hub. And it involves, I don't know, how many teammates, Steve, maybe 6, 7, something like that.
Yeah, on that order. Yeah.
And there are at least 2 or 3 parallel individual threads to advance every aspect of gallium nitride in the power electronics domain. So not power, I'm sorry, RF electronics domain. So.
Okay, great. Is there anything you wanted to add, Steve?
No, but going back to your earlier question about critical technologies, maybe I can help answer that with respect to 5G, 6G.
Yeah.
So with 5G, 6G, that's a reference to the generation of cell phone technology that we all use and has become so important in our lives. So we see how cell phone technology has improved so much, and that how we all watch videos on our phones without even thinking about it today. Whereas, 10, 15 years ago, you were lucky to have a web browser that was very slow. And of course, before that, you were lucky to have a text message or a pager. Yeah. And so the challenge for the Department of Defense is to how to leverage that sort of communications technology in a way that uniquely advantages the United States DoD and takes advantage of those commercial technologies without just adopting the same technology that every other country in the world has access to, and what we can do that uniquely leverages that technology for our benefit.
Okay. Speaking of that, I know you already mentioned kind of what the 5G, 6G project your hub has, but could you kind of explain again what exactly that project is working on in reference to what you just explained?
In the 5G, 6G arena, beam forming is the term that's commonly used. You need to put the energy in the beam, which are higher and higher frequency, exactly where you want it, with multiple users accessing the same data nodes, for instance. And so that project is really about advancing the technologies for that beam forming capability with what are called phased arrays, and in the microwave domain. So there's a lot of very interesting challenges, the technology platforms, but also the packaging is quite critical. So just like the other project, we're addressing every aspect in the supply chain for those phased array technologies, again, with the overall goal of doing what might have taken 3 or 4 years, but doing it in hopefully 1 or maybe 2 years through the hub model.
Okay, that makes sense. Yeah. Thank you so much for explaining.
I can just add to that. Mike referenced packaging, and one of the challenges is that the technology for this project goes from the front end, where there are technologies like GaN in the compound semiconductor world, and the back end where there's silicon, and integrating those technologies together with advanced packaging is one of the key challenges we're addressing.
Okay, I see. Great. So something I've been asking each of the hub leads is about workforce development. So far on my podcast recordings, I've heard a lot about, filling the gaps in the industry and, filling the pipeline in order to build and create a sustainable future of innovation. So I'm wondering what gaps you both are seeing right now in the workforce development and what your hub is doing to fill those gaps.
So our hub is focused in a couple areas in workforce development. One is training technicians to work in the fabs and the labs. We have a clean room gateway program that specializes on both undergraduates and specialized learners. For the specialized learners, we're looking to train them to be able to take jobs in the fabs and the labs within our hub and throughout the country. We have a real need for technicians as we build up our domestic capability. And then for the undergraduate learners, the idea for them is to expose them to the laboratory environment, to stimulate and sustain their interest in microelectronics, to keep them in the field. One of the challenges for microelectronics is lots of students are being enticed by competing areas like AI. Those areas are very important, and we need more workers in those areas too. But we certainly need more people in microelectronics to build up our domestic manufacturing capability. And to do that, we need engineers who are interested in manufacturing and hands-on laboratory work and design.
Yeah, and I think I read something about your micro-credentialing program. Is that right? That was at your hub. Can you tell me a little bit about that too?
Yeah, first of all, I want to go back and say that our workforce development program is led by Andrea Bells, and she's done a great job of putting together all these programs, including the Clean Room Gateway program, which is taking advantage of IEEE micro-credentialing. So the idea behind that, first of all, we are really excited to be partnered with IEEE, and the fact that we're working with IEEE means that the credentials mean something to the outside world, and it's not just an up-and-coming hub who has the audacity to teach a class and give somebody credentials. So IEEE's work with us is very important in that aspect, and we're glad to be partnered with them. And then the micro-credentialing part of it is important because it allows students to come in just for a couple of weeks and learn something about working in a clean room. A clean room is a unique environment to work in. And so it's a great way to identify those potential workers who are interested in working in that environment and capable of working in that environment. And we think that the people coming out of this program are ready to go to work in a clean room, have sort of started to see that pay off already.
That's exciting. Is there anything you wanted to add, Mike?
Yeah, I would add that the IEEE involvement is really exciting and really important. We've observed internal IEEE that it's a high priority, and their connection to the program is rated very important. But I think what makes me excited is that it's an opportunity for us to go beyond our own hub needs, and the IEEE badge of security here allows others and within Microelectronics Commons to use that too. And I know there's interest from at least a couple of other hubs that have come to us saying, how do we get connected to it? So that's exciting too.
Yeah, absolutely. So that's about all the questions that I have for you guys, but I wanted to give you the chance if there's anything else that we missed or that you'd like to highlight about your hub.
I'd like to talk about our collaboration with other hubs and our work with other hubs throughout the program. As we've discussed, our Moses 2.0 service is meant to provide prototyping across the country. And in order to make that its most useful, we want to make sure that we're making technologies available from within our hub, but also from other hubs and other places. And there are other hubs that bring talents that are complementary to the ones that we brought. So we've started off with partnerships with the Midwest Microelectronics Hub and the SWAP Hub in Arizona. Our collaboration with the Midwest Microelectronics Hub is interesting because we are not only interested in making technology from that hub available through our Moses 2.0 service, but we're partnering very closely with them on the platform for Moses 2.0. And the Midwest Microelectronics Hub is providing their design digital platform that will be available for the whole program and for other programs. And so we're working closely with them to put our Moses 2.0 service on that platform. And then with the SWAP Hub led by Arizona State University, we are partnering with them to make their technologies available through our Moses 2.0 service. And we're starting with some exciting technology from Sandia National Lab in Arizona State, working with them to make that available through our service.
Okay. And I should have asked earlier, could you explain what the Moses 2.0 service provides?
Sure.
For Mike.
I'll
Yeah.
do that. Yeah, in addition to being Steve's deputy, I'm the director of Moses 2.0. So it's been an interesting opportunity to build a new organization essentially from the ground up. Even though it sort of has its roots in the original Moses, it's really, really quite different. And we really have two areas of focus, but with some overlap. One is the actual transition from lab to fab. We have a lot of interesting technologies being developed, and they can go, if nothing is done, they may sit and not be used or transition to be used for DoD needs, for instance. So that's one of our missions. And we have a team, Process Integration Engineering Services team, which is the bulk of our folks, who are spend a lot of time on what we call pipe cleaner projects. And these are very interesting projects. Some are small, some are large, internal, funded by the base program, to pick out opportunities for rapid transition or development and transition of ideas. I'll give you one quick example that happened very quickly after we started, and as an example of how the collaboration between industry and universities is accelerated. We had initial kickoff meeting. Engineering leader from Northrop Grumman and nanofab leader from USC were almost literally in an elevator chatting, and they came up with an idea to do a chiplet patterning concept. And one thing led to another, and within a couple of months, we had a whole new approach where we could get chiplets from a fab, say Northrop Grumman. We could pattern them at the university, return them, and now that's a service we can offer. That wouldn't have happened without our Superhub. So that's sort of mission one, the transition. Mission two is to support full flow fab prototyping to accelerate that process through multi-project wafer runs. And we want to do that within our 3.5 services. The Sandia opportunity is a particular indium phosphide photonic integrated circuit concept we're going to run an MPW through. And so but in the compound semiconductor world, it requires more expertise in support, technical support, design support. And that's what our team is doing. So there's the lab to fab part, and then the fab part, if you will, are sort of our two parallel missions. And I would say roughly half and half is what is our people are focused on these areas. So.
Okay, yeah, it's really exciting. It sounds highly collaborative as well. And you mentioned some of the other hubs might be able to use that service. Is that already happening?
It is. In fact, it's really exciting. Right after we got the option year one kicked off, we began our collaborations with the SWAP Hub. And the best opportunity is a particular technology that's offered by Sandia National Labs. And that's the one I just mentioned. So we are, right as we speak, putting together a multi-project wafer run that will be a good test case. We're not charging customers, by the way, for this one. It's a way of building our capability from the administrative pieces all the way down to the technical pieces. And the basic model is we have PIES team members at USC ISI, but now we're going to have an extension of that team to Sandia, and there'll be essentially a PIES team member from Moses at Sandia who will make this happen. So yeah, it's a really, really fun and productive way of collaborating, I think. So
Yeah, that's very cool. Okay, great. Well, is there anything else you'd like to highlight before we kind of sign off?
Well, speaking of collaboration, I just want to mention how unique this program is in the collaboration within the hub, between the hubs, and with the sponsors, including both DoD and STXL. It's really been great the way everybody pulls together and is working to make the program a success. And I want to highlight the interaction that we have with the CT leads, the Common Technical Execution Area leads. We've been working with the CT leads in the EW and 5G, 6G area. They've made multiple visits to tour our facilities and work with our researchers in the first year of the program. And it's really important that we have an understanding through them of the DoD needs and are able to make sure that what we're doing is aligned to the department's needs. And that it's great the way everybody has worked together to help us achieve that.
Yeah, cool. So honestly,
can I just amplify that, because I was trying to explain to my wife what we're doing here, and I think we have, as Steve said, great collaborations between government and SDXL and all the other hubs. And I think somebody pointed out, well, it's like you're all in the same boat together, which is true, but it's like we're all in the same boat together, floating down the river, designing and building the boat on the fly. And that's what makes it very interesting and challenging.
Yeah.
So that's just sort of how I explain what we're doing.
Designing it as you're floating down, trying to stay afloat. Yeah.
And Sydney, NSTXL's role is so important too, with all the communication and coordination of all the deliverables. There are so many moving parts. The chess effort to line up EDA tools for the projects in the hubs. All that is so important to make this program work. So we really appreciate NSTXL's contributions as well.
Yeah, that's great to hear. Awesome. So if someone wants to get connected with your hub, if they're interested in collaborating or, getting connected, how could they get in contact with the hub? Should they reach out to you, reach out to the website?
They can visit our website, which is ca-dreams.org. That has a contact button that will go to multiple of us, and we'll make sure we can get back to us. We also have a relatively new website, moses2.com. That's Moses, MOSIS, the number 2.com. And that has the ability not only to contact us, but to set up an appointment with an engineer on our PIES team for our Moses 2.0 service and talk about how we might be able to help with your prototyping needs.
All right, well, I just want to thank you both for coming on, for explaining all that technology to me, and really looking forward to seeing all that CA Dreams does in the future.
Appreciate it.
Thank you, Sid. It was great talking to you.
Of course. Me too.